Okay, so thank you everybody for coming today. We're happy to see that many of you have chosen to register for this seventh webinar. The topic for today is gathering material information. So as usual, we have received new ideas from some of you, and thank you for that. We'll do our best to address these topics in the coming webinars. Last point before we start, as mentioned in our email, we want this webinar to be interactive. So please do not hesitate to use the chat feature to ask your questions. And since you're all muted, and I will monitor the question and answer on the go. Today, we are going to give you an overview of the tools at your disposal to view and generate material data. We will also introduce a homemade Excel tool that was developed to help you and us. Goal being to introduce these functionalities into a global tool that will be included in our products in the future. So now I will let Sergio, technical support engineer, lead this webinar. Sergio, please go ahead.
Okay, thank you, Nicolas. So today we're going to talk about the different type of simulations and the material data we need to input for those simulations. After that, we will talk about some external tools that we can use. And then we will give an introduction to a final tool that we are going to introduce in the near future that pretends to unify all the material data in a unique place. Let's start with the different simulations and the material data we need for each type. Okay, a quick introduction first. As I said, we need different material data depending on what we want to simulate. The equations are going to be different for high deformation for a heat treatment. We use different models to simulate those things. We're going to consider high deformation for any material flow that is significant. For example, heat treatment simulations will not be included in high deformation because they deform really slow. For high deformation, we normally use tables that combine temperature, strain rate, and stress. We'll show an example later. For phase transformation, we need TTT curves. We need to introduce this information somehow. For grain size evolution, we need to define a recrystallization model. And all of these will be explained in detail in the following slides. When we want to use the default materials in our software, the default library we have to use a store, of course. And here, it's important to know what we are using for our simulation. For example, if we are in a hot forming simulation, we cannot use a cold forming material because the equations, the model will not make sense and the results will not be accurate. So it's really important, I have added a comment here, to use the material accordingly to the simulation conditions and the results we want to obtain. If we want to obtain grain size evolution as a result, we'll need to enter a recrystallization model. To do that, first we'll have to decide if it's a hot forming or cold forming simulation. If it's a hot forming, we have to go to this section. And once we are there, we can go to tags, and you'll find recrystallization as one of the tabs. So you have to apply two filters for the grain size, for example. If you want a phase transformation material, we have to use a TTT curves. We have some default materials in the TTT section. And for high deformation, please make sure you differentiate between hot forming and cold forming. Okay, so high deformation. In high deformation simulations, we use these type of tables to calculate the stresses. We combine strain rate temperature with flow stresses values. This type of table is obtained through experiments testing. We have a lot of materials in the default library, so 99% of the cases you will find your material in the default library or a similar one. If you cannot find it, you can contact us and we will help you to find a solution. Using this data, what we do with most material files is calculate the Hansel spiral parameters. It's a way to translate all this information in a small number of parameters, as you can see here. If you use a text editor to open any of your material files, the default ones, you will see something like this in the text. These are the Hansel spiral parameters. And something very important here is the range of temperatures for these for the parameters. This material file is the C45 for the hot forming simulations. This means we have to stay in this range of temperatures for these parameters to be accurate. Otherwise, the results will not be as accurate as we want. So please make sure you stay in this range of temperatures. Okay, I get a lot of questions about when should I consider my simulation to be a hot forging. You have to go to your material file and check the range of temperatures. You want to stay here during your simulation. If this range is not enough for our simulation, we can do several things. We can extrapolate the Hansel spiral parameters for a wider range of temperatures, and we can help you with that. Please contact the support and we will assist you with that. Also, you can just import the complete table instead of using this adaptation with the Hansel spiral parameters. We can just import the whole thing as a data file. That's also possible. Contact the support and we will help you with that. And the last option is to use GMAT Pro. We will talk about this solution later. So when you import your own experimental data coming from testing, we will use the disk option to import the material file. If we want a default material, we have to use the store option. I wanted to mention a tool that we use when we cannot find our material file in the store. If you go to the store and your material file is not there, the best practice here is to try to find a really close material in terms of chemical composition. To do this, we can use the Rheology database tool. It's in the Home tab, and it's on the bottom left, Rheology database. When we click here, we will be taken to this interface. What is interesting is the search option right here. Clicking there will open this new Find interface. Here, we are going to be able to use the chemical composition as a filter to filter all the materials in a category. For example, if I want to steel with, let's say, percentage of chromium, and I don't have the exact percentage I want, I could filter all the materials and say I want to, if my desired percentage is 5%, we could show everything between 3% and 7% to choose one that is close enough to our material. If you have doubts about this and you are not sure if the approximation is good enough, you can also contact us and we will help you. Next, for cold forming, you can use the default materials, but in order to be the most accurate, you can use the cold Rheology generation tool, again in the Home tab, bottom left, to create your material file. This is actually the best practice for cold forming because it's a really easy process. you just have to enter your material parameters in here. They are really, they are not hard to obtain. You can easily obtain these parameters from your material provider or even online. A common website is MatWeb. There's a lot of material files in there, material properties in there. Once you have introduced your material properties, you can just have to enter material name, type of material, could be steel, aluminum, etc., and export it. It's a really quick process that doesn't require normally any experiments or testing because these properties are available, and it will let you to create your own material file specific for parameters. Okay, now for phase transformation, we are done with high deformation. Now with phase transformation, we are talking about, for example, a heat treatment, quenching, those type of simulations. To simulate phase transformation, we're going to need TTT data. There are several ways to obtain this data. It could be through testing experiments. For these, once you have the curve, we can help you in the support to adapt this data to the Forge format. But it's just importing the curve. That's all we need. Another way to obtain it is through GMAT-Pro. We'll talk about that later. It will let us to export TTT curves directly to Forge. We will not need to adapt the material data. Finally, we have the Ptt Cct Diagram Generator. In the last webinar 2 weeks ago, we explained this tool in detail. So for reference on this, please check the heat treatment for steel alloys webinar. For grain size evolution, as we mentioned in the introduction, we will need a recrystallization model to simulate this. This requires some, some testing. So normally these parameters are not as easy to obtain, or they are not so easy to access. So it's really common to use default materials in here. To access the default materials for recrystallization, remember you have a dedicated tag. That's how you filter them. Also make sure if you are in a hot forming simulation to access only the hot forming materials. If the material is not in the store, the best practice would be to find the closest one. So we will filter hot forming recrystallization and try to find the closest material in terms of chemical composition. Once we find that material, we are going to copy paste the grain size block. It's the way we add the recrystallization model is with a text block in the material file. So if this is the closest material in composition, I can open it with a text editor. We recommend Notepad++. It's free and it's really good for visualization. Once we open it, we're going to find these keywords, user bar and fin user bar. Everything between these two is what we need to implement the recrystallization model in our material file. So yeah, it's just a copy paste. We're going to copy this recrystallization model from the closest material file in our material file. And the only thing we need to edit after that is the initial grain size. If we look in the block, we'll find user variable initial diameter. Here, we'll have to select if we want ASTM or micrometrons and select the value. In this case, we have 4 ASTM. It's important to know the initial grain size, so please edit this before starting the simulation. And that's all we need. Once the material is ready, we can import the material file using the disk option and run the simulation.
Sergio, we have a question from Rochan concerning code forming. It's asking if there's a way to incorporate strain range dependence in the tool for code forming. You want me to answer that?
Yeah, sure.
Yeah, so Rochan, no, there's no, the tool will not allow you to do that just because we consider there's no strain rate dependence in code forming. Now, I'm going to show you in the Excel, we can do that with this tool that we have created. So if you need a strain rate dependence in your code forming material, you can do it. It's not direct, but you'll be able to do it. So we'll show it. We'll show it next.
Yep. Okay. There are many things we can add to material files with text blocks. So if you have a similar question like that, you can email us to the support, and we will try to help you and find a block that we can add to the material file to get that extra result or make a parameter dependent on another parameter. We can do those type of things with text blocks. So don't hesitate to ask any of those questions. Okay, so just to summarize, if we don't find the material in the store for grain size evolution, we can use a standard hot forming material and find the closest recrystallization model that is in the default library, get this block including the recrystallization model, and copy paste it in the material file we want to use for our simulation, which should be coming from the hot forming this case. All right, moving on, GMAT Pro. So many of you know this software. This is an external software, simulation software, that will generate material data based on the chemical composition. So how this works, we will choose the category. Right now it's working for steel, titanium, you have it here, and aluminum, cobalt, and nickel alloys. All those materials will have a direct export for Forge. Once we have selected the category, we just need to enter the chemical composition and a couple more simple parameters. But the main thing is the chemical composition. After that, the simulation software will generate material data and it will export it in a format that you can import in Forge directly. So it's really easy, and it will generate really accurate material data for your case because it's specific for the chemical composition you are using. Also, it can be used to obtain TTT information additionally to the stress parameters. And the TTT only works for steel right now. The main drawback from this is that only uses international units, but in the tool that Nicholas is going to explain later, the Excel tool, we have added a section to transform these GMAT Pro material files from international units to imperial units. So that shouldn't be a problem anymore. The main advantage of the material you generate with GMAT Pro here is that it doesn't have a range of temperature. You don't have to be worried about being a cold or a hot forming material because it exports this data for a really broad range of temperatures. You can use them both in hot and cold forming. Also, it has a large domain of deformation. This is the strain, and the strain rate is also really, the ranges are really high, so you don't have to be worried about that anymore. If you want more information on this, please email us to the support, and I will send all the details. Okay, now I'm going to let Nicholas introduce the Excel tool that we have mentioned. He has worked with this mostly. So I need to make him the presenter.
I'm the presenter now.
Okay. All right.
So I'm good.
Great.
Thank you, Sergio. All right. So let's talk about this Excel. All right. So we've developed that because for a number of reasons, and for a number of software as well. Okay. Still in development. We are developing that internally. So we try to support it as much as possible. But there's probably some flaws in there, okay? So bear with us. Anyway, the goal, again, is at some point to introduce all of those features into a global material tool that will be available within our software. You've seen Sergio has introduced like several tools that you get from these how you call it, the background in Forge. The idea is to have one tool that will have all those in there. Anyway, so I have selected three cases I'm going to show you. First one is just simple Excel field. How to load an Excel field, which is the basic materials you have in Forge. Give it the data and generate curves so that you can look at your material in a comfortable way. And since it's Excel, you'll be able to modify whatever you want. Okay. On top of that, you can from that generate a new material with additional data in terms of physical data. So thermal conductivity, young modelers for conformings, and things like that, density that will be interdependent, which is not the case in the default. Then we'll see about GMAT Pro. I'm just going to upload a file. As Sergio mentioned, when you export from GMAT Pro, it's only in international unit system, in the SI, so you'll be able to convert into a PSI unit. Okay, so that was actually the first point. Okay, so first, it's XLSM, okay, for macro. So when you open that, you need to enable the content to enable the macro. Okay, well, just be aware of that. Also have created in this tab here a manual or guide. So you have a lot of content here and videos that you can access. They are here, so you have all the demos. You can access it to learn about this tool. All right. Also, a number of tabs. They are not locked, so you technically can remove and delete them, but I will suggest not to do that. So here is SI for the stress, and in PSI, physical data that we have already in there with graphs to look at them, and the PSI. Knowing that if we look at it, for now, I haven't done a macro to convert one way or the other. It just goes from SI to PSI, but if you do into Excel, you can just do it, and there's the values here, so you're already good with that. But it's part of the improvement that we are planning to do on that. Also, we have some .tmf, which you may know is the format we use for material. So we'll see that we can generate a material with this tool. Okay, and we use those templates. Okay, and here there's nothing to change actually. They are just there to be used. Also, so I will put that on our website in the name area. I'll show you after. We'll do a version without the Run 3D features, obviously. It's not of your concern for now. So we'll clean that up a little bit. Okay. All right. Anyway, so for now, let's do Entropy schedule. So first thing I'm going to do is import the material file. So I'm going to click on that and go grab my file. So I have one here, and that's one in PS, actually 4130. So bring it in. You see you have one more sheet here. It's been updated. It's here. So as you can see, you have all the data, the parameters we use. And if we look at the physical properties, it's only one value. We use constant values for the physical properties, okay? So most cases, it's all right, but when you go down a little bit in temperature, it might be a problem or a concern. Right. So first, if you want to see the data, and when talking about the data, it's mostly the stresses. So see the stress strain curve. I need to first gather the data from Ench Hospital. Okay. So first, I'm going to select my sheet, which is here, and then click on that, and here it is. Okay. So you have all your data here. Okay. Now, what I'm going to do is from that, I'm going to generate the stress. The stress is in a tabulated fashion. Okay. So for that, I'm going to use the stress generator. And actually, I should have done something else. I need to take the template. So template, it's in PSI, so I'm going to use the PSI stress as template. Okay, so that's what I'm going to use. Those are keywords, don't have to worry about it. Basically, you don't want to do anything here. You can do an auto conversion. It will convert automatically at the end, but we'll do that separately. And is a little bit more complex, where you can generate your own material based on several values, parameters here. And by the way, to answer Rochan's question, that's what you would use to generate your material with a temperature dependence. Sorry, strain rate dependency. Okay. Anyway, we have a limited time here, so I'm just going to show you that. So I'm just going to click here, and right, the stress has been calculated into the PSI stress. So what has been done here is I have used the data that we had here. Okay, so I had the preparation, and I show you here. Basically, that's how I looked before I hit the button. Here's the number of strain rate. This is the number of, this is the number of strain we have here, number of strain rates here, and then the number of temperature values. Okay, so you can change those values to adapt to whatever you want, or just the default, which actually are not too bad. Okay, so those are obviously translated here with the right, mostly for the temperature, with the right unit, and the tools just generated all of that. Okay, so now we want to plot those. Okay, so how we do that? We're gonna use the create Excel data from original file. Okay, so I'm going to click on that. This gave us automatically the information we need in terms of how many temperature values we have, how many strain rate values we have, and how many straight values. Okay, so we gave it that directly from the template that I had selected, which is the PSI stress. Okay, here I'm going to generate to create a new tab, or you can use one that is already there. Just put the name. So I'm just going to do that and click OK. So here it's going to take a little bit of time, and here it is. It has generated all the data we need. So the way it generated this is you have a title with what is the temperature of this data and what is the strain rate. Okay, and then it's temperature and strain. Okay, so those are the values. So that's the temperature and that's the strain rate, and then the stress and strain. Okay, and etc. It goes on forever. So you can plot directly those data. So if I select the demo stress and say, okay, chart generator, you have the list of all the data here. You can click on that and just select the one you want. Okay, I'll just click, plot everything. Here you can plot it into this sheet here, or say, no, I want it in the new sheet, so I'm going to put that here. And that's about it. You can change the title if you want and resize the chart scale. But let's do that. So here's just generating the plot. The only problem we're going to have with that is it's a lot of data for one plot. Okay, so here's created. So you have all data, but as you can see, it is a lot. Okay, so what we did, we're like, okay, let's generate a plot by strain rate, for example, and have all the temperature for all the strain rate. Or say, well, I want for one temperature, I want to see all the strain rate. Okay, so we can do that. I'm just going to delete this. Now, what I'm going to do is use this button here, the data generator by selected category. Okay, and I'm going to select strain rate here. So strain rate will be my reference, and it's going to generate a bunch of data base for each strain rate. Okay, so it's going to take a little bit of time. So we're going to go over today because it might take some time. So hopefully still reverse. All right. So there's a lot of data, so it's taking some time, obviously. Okay, so what it has generated here is you can see all the new tabs, and the tab's name is basically what is the strain rate used for these. Okay, so if I go there, I see it's for the strain rate. I don't know, it's 110 minus 5, I guess, something like that. We have those values for this temperature, this, and this, okay? And etc. for all of them. So now I can just select the one I want. Okay, so you can just use the control button to select the one you want, or what I'm going to do here, I'm just going to select them all. Okay, and then from there, I'm going to generate charts. I'm going to use all the temperatures. I'm going to generate one new sheet for each new graph. Okay, the title of each chart will be by default the name of the tab. Okay, so it'll give you a strain rate. You can change that over. All right, so that is magic now. And here are all the charts we have. Okay, and they are prompt. Okay, so now for each strain rate, you are able to plot all the data. Okay, and again, it's Excel, so then you can do whatever you want in that to zoom close and etc. Okay. All right, so that's how it works for Ensure. So once you're satisfied with that, again, what you can do is go here, physical data, and just tabulate with temperature here, and your modular thermal conductivity, and Poisson ratio, density, specific heat, and linear expansion. Okay, linear expansion, by the way, be careful, it's in percent. Okay, so just give us a call when you get there. Here you have the graph showing all that, so you can change the values to adapt to your material. Okay, so once you've done that, what you can do is create your new material file, force file generator. Okay, so here actually, yeah, so a bug here, so I'm going to delete all of that. It's for some reason it doesn't list when there's too many sheets in the workbook, so I'm just going to delete all of them. There we go. We don't need that. So force file generator. So here I'm gonna give a file name. So I'm going to call it demo material. Here I'm going to select the TMS template sheet. So it's what I introduced earlier. So here it's in PSI, so I'm just going to use PSI TMS. Then stress data, I put them into PSI stress. Could be a different file if you generated a new file or a new sheet, doesn't matter. And then they're gonna pick the physical data sheet. Okay, that one's gonna be here. Going to select the export folder here, and then that's going to be my folder. Here you can put generic comments, general comments, and I don't know, my file, and then here you can put a material category. Here, whatever. Okay, and then click OK. Gonna take a bit of time too. Very sorry, we're gonna go way over. The GMAT Pro should be faster. I'm not going to show you all the chart generating because at some point it's exactly the same. Let's go. Okay, so it has generated that. So here now you have your material file, and it's in GMAT Pro format type of. Okay, so here you have all your physical data being generated. Okay, based on what you have in the Excel. Same thing for the stresses. Okay, and same thing for the TMS. Okay, TMS. You have the comment here, my file, and then material category, and automatically has generated all the information you need. So you can use this TMS file directly in your simulations. Just keep the 3 files at the same location. Okay. All right, I'm going to speed up a little bit now. Now, the other thing I wanted to show you is about GMAT Pro. Okay, so mostly there's 2 things. First is to generate the charts the same way we've seen, and also the other point is to convert. Okay, so here I have an example. So I'm going to use this, which is the stress. That's mostly what we are dealing with now. Okay. So here I have my file. Okay. So when it comes, you have those 2 extra columns which going to cause some trouble. So what you can do is select the sheet here and use the GMAT Pro sheet cleanup. So it's going to remove those 2 columns automatically and get something clean. Okay, so if I go back here now, they are all lined up properly, so we're good to go. Okay, so from this point, you use exactly the same process. You go to create Excel data and data generator by category and chart generator. Okay, it works exactly the same. All you select is this sheet now. Okay, so there's nothing else to do. In terms of conversion, all right, we'll click on convert. So we are going to the internal PSI, for example. I'm going to select my reference sheet, which is the INCO 718 F stress, and I'm going to say I'm going to convert from MPa to so megapascal to PSI, and from Celsius to Fahrenheit. Okay, so you can use the other way around if you need to. And that's it. And then click OK. And that's it. This has been generated, and now it has the values that we needed. This was in Celsius, okay? And then both are in Fahrenheit, and the same for all the stresses. Okay. One thing that we need to improve, as I said a little bit earlier, these convert only the stresses for now. Okay, so it doesn't deal with physical data. Point is, for now, you know, it's easy because it's column. It's by column, so that's kind of easy to just do it automatically in you know, in Excel with these values, and you already have them in the template I will upload. Okay. All right. Sorry, it took longer, but that's it for this Excel tool. Again, what I'm gonna do, I will put it on the member area. So it's translaterusa.com. You click on members. You have to log in. If you don't have a login, you have to sign up, and I will approve your request. Okay. So here, what you see is all the webinars, by the way, will be here. So once that one is done, I will upload it in there, and you can review all the webinars we have done. Okay. You have all the videos here. You have the download for the latest versions. So all of that. The tool will be into Forge How-To, and I will put it into the tools here. Okay, so we have a bunch of tools already, and I will upload it in this. Okay, so we have some another tool here. Okay, sorry, took longer. Now back to Sergio. I think he has one more topic to talk about. Sergio, go ahead, you're on mute.
Yeah, thank you, Nicholas. So we have reviewed the Excel tool. Now we are going to introduce a final thing. It'll take 1 minute. It's the material data tool. This is the future for material data in Forge. And it's going to be a unified solution that will include all the material blocks we have been talking about during this webinar. You will be able to import your TTT information, your high deformation hot material data, and also your, sorry, if you have your recrystallization model, everything will be available here. We have a version working right now in Faircast. It's a first version. This is our casting simulation software, but it will be implemented in Forge in the near future. We are not sure which version, but some features will be included in each version. It might take a while until the whole module is available, but it will be slowly introduced. It will be a tool in the Home tab. This is for Faircast right now. It's called Material Data Tool. When we click in there, we'll see this interface, and we will be able to import each property in the different tabs. We will have an alloy properties. Here we'll have the TTT information to be imported from there. We'll have a grain structure. Again, this is in construction right now, but I wanted to mention it as the future for material data. Sorry it took a little longer, but this is all we wanted to show today. Thank you for your attention. We will answer any questions you have now.
Thanks, Sergio. Again, thank you all for being here this morning. Sorry it took longer, but is there any question? No. Okay. So as said, this webinar is recorded, and we'll have it available in the member area, as I showed you. We will communicate also when the video is available. So for the next webinar, so we're still working on topics we want to show we're debating we might do some maybe shorter webinars, like focusing on a specific topic. So we'll see. Also about the pace, we're a 2-week pace now. We might review that. I'm not sure if we're gonna keep a constant pace like that. So just look at your emails. We will send the announcements obviously when it's ready. It might not be in 2 weeks. We'll communicate on that based on how much we have done for the next webinar. Okay. If you have any questions, obviously, please feel free to email us at support@transvaleuramerica's.com or use the web portal on our website, transvaleusa.com. Thank you very much, all. I hope you enjoyed this webinar, and we'll be in touch very soon. You all have a good day and a good weekend. Bye.